let's start. Okay, so the first, symmetric algorithm, which is in use in many, algorithms. It's still there in IPsec at least. Okay, it's called the DES. Now, DES is a pretty old algorithm brought in 1977. The form in which it is being used today is called triple DES. Okay, knowing this much is more than enough. Okay, but if you want to go into further, you can do a little bit, more studies and get to understand what are the modes in which DES works. Okay, then DS was broken pretty easily. It was 56-bit. So then came the triple DS. Okay, triple DS is still in use. Effectively, it's of 112-bit length. Then you have a symmetric key cipher called IDEA. Okay, IDEA is a cipher key which is used by 128-bit cipher key. It's again a symmetric key. It was used in a very well-known application called PGP, Pretty Good Privacy, pretty famous in 2003 to 2008, which could be used for sending, emails, right? Then you have a symmetric key cryptography algorithm called Blowfish. Now, Blowfish was a a variable length symmetric key. You could use from 32-bit to 448-bit keys for using Blowfish. And then you had a algorithm called Skipjack. Now, Skipjack was a algorithm proposed by US government and said that whatever keys you use, we will keep the copy of the key in a key escrow. Okay. Now, the security community was not ready to accept this concept, and this particular algorithm was not adopted by the security community. Okay. Now, once we see asymmetric algorithms, the one of the most famous and used algorithm is the RSA. Okay. Now, RSA are three guys, Rivest, Shamir, and Alderman, who basically, gave asymmetric algorithm, the RSA algorithm. Previous to that, they are all mathematicians who gave RC4, RC5. These were all, symmetric key cryptographic ciphers. You don't have to remember all that. It's just for information. AES was a public key crypto system which was developed by NIST, okay, for use of federal and civilian systems. The NIST held a competition and it replaced DES algorithm after a competition was held. Okay, and AES became the finalist. Right. AES has three strengths: 128-bit, 192-bit, and 256-bit strengths. AES has still not been broken or brute forced. Still not. Okay, then there are other algorithms. CAST is another algorithm which is a symmetric key cipher. Twofish is another algorithm which was AES finalist, but it didn't win. The algorithm which won was the AES, right? Okay. Small question. I don't want you to, I think it was Twofish, which was used by, IDEA, which was used by Phil Zimmerman. Now, Phil Zimmerman was actually arrested by FBI for, creating a encrypted emailing systems, right? Just for information. At times, such questions do land. Okay. Now, we saw that symmetric key, distribution and management is a major problem, right? You have 28 keys. How do you distribute them? You cannot distribute it in band. You have to go out of band and distribute them. Therefore, symmetric key crypto systems can be used in such manner. Say, we all want to, exchange keys. We trust a third party, which is a key escrow. And we deposit the key there. Whenever we want key, we get the key from here. But what if the escrow itself gets hacked? All your keys are given away. Okay, so escrow systems is not a very good concept, but can be used for key escrow mechanisms. Okay. Asymmetric key cryptography I have already explained. Okay, algorithms are, first is the major algorithm which is in use is the Rivest, Shamir and Alderman algorithm, the RSA. It is the primary algorithm which is in use. The second algorithm which was used is Markle, Hellman and Knapsack. Knapsack is the person who made, along with Elon Musk, they made a music sharing application called Knapsack way back in 90s, right? And El Gamal is another, algorithm which can be used for symmetric key cryptography. Knowing this much is more than enough. Also, you use something called elliptic curve cryptography. Now, elliptic curve cryptography uses mathematical functions based on maths of ellipses. Okay. So you basically use the maths of ellipses and find two places which are correspondingly generate a key, right? We don't need to go there. But the best part about elliptic key cryptography is that the elliptic key cryptography of 160-bit is equal to RSA 1024 strength. That means ECC is much more efficient. It's an efficient cryptographic system. Okay. Now, this is where I was telling you that how do you use public key cryptography to exchange a session key. Okay. Now, suppose Alice and Bob want to communicate to each other. What Alice will do is Alice will take Bob's public key and Alice's private key. Okay. Her own private key and Bob's public key, which is available. And it combines a key. What happens is you get a shared secret key. Okay. And what does Bob do? Bob also takes Alice's public key and combines it with his private key. He gets the same key. That is the property because it's prime number factorization. Once they do this, what they have is the session key. They do not need to exchange anything. They just need to use this as the symmetric key for doing a session. This is called Diffie-Hellman key exchange. Okay. No major, maths. You just take your private key and their public key and you combine the keys and you get a common key. And that's the shared secret between you and your receiver of the data. Okay. Very commonly used in TLS, IPsec. Okay. VPN formation, very commonly used. Right. Now, this is part of 2024 quantum key cryptography. Now, what has happened is the quantum is on the horizon. Now, what is quantum computing is, you're saying that if you look at normal computing, right? If you look at normal computing, what happens is you have a silicon chip, okay, or you have a germanium or a silicon chip, okay, which are used as switches to implement zeros and ones. Okay, the silicon chips, they work as a flip-flop and they have two states, 0 and 1, whether the switch is on or off condition, right? And you have such multiple switches designed inside your chips, right, who are capable of storing or processing the information. Now, once quantum computing comes in place, what quantum computing says is that I can represent 0 and 1 with a spin. Okay, look at the spin. Now, any particle which is rotating on its axis can have infinite spins. That means you can break down the spin into infinite values, right? You can keep dividing it practically. At the quantum level, you can keep it dividing. And every time I move clockwise or anti-clockwise, I can say 0/1. I move clockwise, I get 0. I move anti-clockwise, I say this is my understanding 1. Now, how fast this quantum particle you can keep moving, you can generate the bit sequence 0, 1, 1, 0, whatever you want to. Now, the best part about quantum spin is that quantum particles exists in pairs. And if I move it clockwise, this will move anti-clockwise. And you can separate these two particles infinitely. And for this behavior to be shown, the temperatures required are minus something, something, something. It's not minus 273 at least. It's very, very low for particles to behave in a quantum manner. Now you imagine if I want to transmit a very high degree of information without anything, I can just spin this particle and the other particle will spin there, and they are separated by distance. And this fundamentally is being used for getting quantum computing speeds. Also, this is the logic for quantum communications. That you exactly don't need anything. You just rotate this particle here and the other particle is also correspondingly rotating. Okay. This is the quantum theory base. This is the relation. This is the quantum relation between these two quantum particles. Now, the main concern in the cryptographic community is that once quantum computing speeds are reached, whatever you have encrypted today using AES 128 or 256 can be easily brute forced. And that's why you need to prepare quantum ready algorithms now. Because whatever you're encrypting right now, hackers are storing that data. They are not able to decrypt it. They're waiting for the day when they have access to quantum computing. And if it is there in the horizon in the next 10 or 20 years, they will be able to decrypt a lot of data. So that's why scientists and mathematicians are pushing for quantum ready algorithms. Okay. Right. Then we saw hash functions. What are hash functions? Hash functions are one-way functions. You have SHA, MD5, and RIPE-MD, which are the most commonly used hash function algorithms. Digital signatures I've already covered. Okay. HMAC is another way of, HMAC is a protocol actually, which implements what we discussed in digital signature using the HMAC format. So HMAC uses, once you say signed by HMAC, HMAC is a protocol which is used for digitally signing your messages, right? It implements the same fundamental which we saw in Alex and Bob example. Then you have, for digital signature, you have a standard. It's called DSS. Okay, DSS is a standard under FIPS 186.4. It's a US standard wherein you can use DSA, RSA, and elliptical curve DSA for creating electronic signature. So DSS is the standard under which you create the digital signature. Okay. Okay, I discussed this, not of any relevance. Now, once you saw Alice and Bob, they both introduced private keys and public keys, right? Bob also generated a private key and a public key. But now you saw that if I want to send a message to Bob, I need access to Bob's public key. How do I know this is Bob's public key? You need a third party. And that third party is nothing but the PKI, the public key infrastructure. Okay. India has its own public key infrastructure. Government has created a public key infrastructure which issues you a digital signature key. And that key is nothing but this private key which it issues you. And it throws the public key into the PKI. But for issuing you this PKI, they first do a KYC wherein they take your Aadhaar card, your PAN card, then they have a video KYC, then you get a telephone call, verification, all this verification happens, then only you are issued this key and you write this key on a physical dongle and keep it with you. There are three types of digital, keys: class 1, class 2, class 3. Okay, just to give you an example. And that's why you cannot pick up the public key just from anywhere. Either you pick up the public key directly from Bob, but then again, it results into something of a symmetric key arrangement. That's why you need to push this public key into a PKI. And how does PKI work? PKI has something called a certification authority and a verification authority. The verification authority does the verification. They ask for a KYC, Aadhaar card, and everything. And the verification authority tells the certification authority that yes, you can issue the certificate. And certification authority sends the private key to the person who has applied. Okay, and puts the public key into the repository. Now, once your private key gets exposed, if you by any chance your private key you lose or somebody hacks your private key, you are supposed to inform your PKI and they revoke your private key. That is the first part. And automatically the private key is discarded after 1 year. That means you have to create a private key once every year. Got it? Because automatically your private key is discarded. Many times you would have seen websites which are pretty genuine websites. They show that its key has been revoked. Why? Because they forgot to renew the key after 1 year. And automatically their website is showing this website is HTTP. HTTPS is their key has been revoked. Many times red color comes on the. Why? Because they forgot to renew their private key. Clear? Right. So digital certificates have a certain format in which the protocol speaks, and that format is called X.509. And this is the format of the digital signature. Okay. These are all just no things. Okay. Certificate authority, what they do, they identify that you are the right person and you need to be given the, they take all the data from you and they register you on their platform. Okay. Certificates, when they live their life, as I told you, they need to be revoked. They need to be destroyed. And generally the time cycle is 1 year. Okay. Now, once the certifying authority has put your public key on the repository and given you the private key, how do you store the private key? Okay. You have to save this private key. What do? You put this private key either in your TPM module that is inside your laptop. There is a TPM module. There's a cryptographic module where you can store it. Or you can put it in a HSM module. HSM. HSM is a hardware security module. Those blue colored dongles which come where this key gets stored in an encrypted manner. Okay. And you access this key using some particular software which is developed by the HSM module manufacturer. Okay. Right. Okay. Then you saw hybrid cryptography. I told you asymmetric key cryptography is a very difficult, it's not fast. Okay. So whenever you need speed, you need to have asymmetric key cryptography to create a session, exchange the symmetric key, and then you carry on with the symmetric key. Okay. Cryptography is applied in many places. You use hard disks these days, which have cryptography, or mobile phones have cryptographic modules. Email security happens with SMIME. TLS is used for browsing, websites securely. Okay. SSL and TLS both are used. SSL is, discarded now. You only use TLS, right? And you use steganography and watermarking. If you want to put watermarking, hidden watermarking inside your proprietary documents, you use steganography and watermarking. What is steganography? Hiding information inside pictures. So you have pictures, on the pixels, you hide the information, and special software is used to read the information. Okay. In many organizations, steganography is banned, and you have data loss prevention softwares which actually check for steganography and watermarking. Right? How do you, you use cryptography for network encryption? And what are the most famous way of encrypting using, applying encryption in networks is by IPsec or creation of VPN. Okay. We will see IPsec and VPN in more details in chapter 4. Just to let you know, IPsec is a protocol used to create secure network sessions. Okay. So what happens is, if you want to, if this is your enterprise boundary, right? These are two enterprise boundary, A and B, and this is the public internet, right? and you have your own network of computer, okay, and you are speaking through a firewall, through a router, okay, and going into the public domain. And then you're again reaching and now imagine that this is a corporate office with a headquarter in New York, and this is in Delhi, and they want to function as one network, a hidden network inside the internet. So what you can do is you can create something called a virtual network, a virtual encrypted network that looks like as if you are working on your own network. Okay. And such kind of tunneling can be achieved using a protocol called IPsec. Okay. Also commonly known as VPN, virtual private network. Now it works in two modes. It works, device to device. That means each device here can create a tunnel between each device here. Okay. This is called transport mode. That means each device has an independent secure session with any other device there. And you can also have encryption from one terminal to one network to another. That means from the edge of the firewall to the edge of this firewall. Okay. Beyond that, you are not worried. Such networks are called, such IPsec or VPNs are called tunnel mode. Why tunnel? Because all the information which is going here from is unencrypted. The moment it enters the tunnel, it gets encrypted. It's called tunnel mode. Okay, so that's why tunnel mode and transport mode. Transport mode means I'm taking you from somewhere and dropping you somewhere. So there has to be some kind of addressing which is required. Okay, we'll see it in more details once we go into domain 4, that is communications and network security. Now, what are the emerging networks which are now coming, emerging applications of cryptography? First is blockchain. Now, blockchain is completely based on symmetric and asymmetric cryptography operations, completely, okay? And it utilizes hashing to a very great extent, okay? So it's an application of public and private key cryptography to create a trusted chain, okay, and anonymous chain where you can transact value. Okay, that is blockchain. Then you have lightweight encryption. What has happened? If you look at a lot of small devices like your phones, your headphones, your pens, you've got so many IoT devices, and you might get hacked. So you create very, very small form of lightweight encryption, which can be embedded into these devices so that sessions between these devices and the master devices are secure. Such applications are being developed for IoT applications. And finally is homomorphic cryptography. Homomorphic cryptography, as we said, then when the data is put in use, okay, that is inside the CPU and the RAM, how do you ensure that some side channel attack does not take place and the data is not stolen? So what you create a virtualization session inside which you execute the encrypted data. Such kind of cryptography is called homomorphic cryptography.
Thank you for watching. Don't forget to subscribe our channel.